All right, today we are going to learn about the Pythagorean Theorem. I'm kind of hoping that as I write that up on the board, lights are going off in your head a little bit. Because you probably heard of the Pythagorean Theorem. But more than that, you actually now understand a little bit more about what the Pythagorean Theorem is. What is a theorem?
It's a theory.
Okay, it's like a theory, sort of. It's a mathematical idea that we can prove, right? So eventually, not today, but eventually we will work through a proof of the Pythagorean Theorem to show why it works. But, right, the Pythagorean Theorem says, right, for a right triangle, a squared plus b squared equals c squared. You guys have probably seen this before. So, if I had a triangle like this, the Pythagorean theorem is telling me that 6 squared, which is 36, so if we called that side A, plus 8 squared, right, if we call that side B, that's 64, should equal 100, or 10 squared, because we call that side C. Is that true?
Yes.
Yeah, it is true. So this is a right triangle. There's one important thing about the A, B, and C, which is just that C is always the hypotenuse. What's the hypotenuse of the triangle?
The longest side.
Yeah, the longest side. Which in a right triangle, what will always be true about the hypotenuse?
It's like across from the right angle.
Always across from the right angle. Why is that?
Because.
Would it be a right angle with it?
Okay.
Yeah, probably.
Well, I could draw a triangle that doesn't have a right angle, but the hypotenuse is still across from, like, this angle. I mean, like, this doesn't necessarily have to be a right angle, right? I could make this go way out here, and the hypotenuse could still be across from it. But the hypotenuse of a triangle is always across from the largest angle in the triangle. Why does 90 degrees have to be the largest angle in the
Because
triangle?
then the other two have to be 45 for some, like other.
They have to be less, they have to add up to 90, right? Because, so each one of them has to be less than 90 because of the triangle sum theorem, right? So going back to the very beginning of last week, the triangle sum theorem says that the three angles add up to 180. If one of them is 90, that means the other two have to add up to 90. So they have to be small.
Oh, yeah.
Right? So they have to be smaller than this side, which means the 90-degree angle is always the largest angle. And it's always across from the hypotenuse in the right triangle. Now, I don't have to draw it like that, right? I mean, I could draw it like this, but even still, if this angle is 90, this side is going to be C. This is going to be the hypotenuse.
Yeah.
So what else does the Pythagorean theorem show us? We can kind of use this right now for two different reasons. Okay, the Pythagorean theorem can, one, it can confirm if a triangle is a right triangle. So let's say I gave you a triangle and I didn't tell you if it had a right angle, and I told you that the sides were 1, 3, and 7. You can tell me if this is a right triangle. How?
It's not.
How do we know that it's not?
Because if you add up a squared plus b squared.
Yeah, because 1 squared plus 2 squared does not equal 7 squared. 1 plus 9 does not equal 49. So that means this is not a right triangle.
Could you have a right triangle that doesn't follow that thing?
No.
No. You can't have a right triangle that doesn't follow the Pythagorean theorem. Right? So every right triangle is going to follow the Pythagorean theorem.
No.
Order. Mine.
Micah.
Alright. The other thing that we can do with the Pythagorean theorem is we can find a missing side of a triangle. So for example, if I said this side is 3 and this side is 4, you can find this side. How would we do that?
Oh, by
Just
squaring
3
both
squared
sides
plus.
and then
3 squared plus 4 squared should equal c squared. Right? Nope. Yeah, so I would have to tell you. Right? This is a right triangle. Okay, so 3 squared is 9, plus 4 squared is 16. What's 9 plus 16? 25. So the last side is 25, right?
Would it be 25 squared or with that?
25 squared, yeah. So it's like 625, right?
Wait a
Is
second. How does
that right? That
No,
doesn't
that's
seem
not.
I don't
right.
think so.
How can this side be 4 and this side be 3?
What's magic?
Yeah, wouldn't that be 5?
Oh, 25 equals c squared. How do we solve for c here?
You
Square it.
We square root it, not square it. We squared it and we got 625. We want to square root it, right? Square root, so this side has to be 5. And we're not going to worry that there is also a negative answer to that. So we take the square root. Now, what if the side that they gave us, like let's say this one was 15, and this one was 12, how are we going to solve for this side? Is it
16
still
squared minus 12 squared.
Oh, right? So if the side we're looking for, if this is a right triangle, and we're looking for this side over here,
Looking for one of the sides that's
we're
not
looking
the
for one of the
hypotenuse.
legs, not the hypotenuse. So what we know is that this side, let's call it a squared, or we could even call it x squared, right? Doesn't really matter. Plus this side has to equal the hypotenuse still. So now we're going to be subtracting, right?
Yeah.
We're going to do 15 squared minus 12 squared equals x squared. So on my calculator, 15 squared is 225. Just a quick note about most, like if you have one of these simple calculators, you can usually, to do squared, you can usually just do times equals, and that squares the number.
Oh, really?
Yep. On a really simple calculator.
Oh, yeah, it does.
So 144 equals x squared. So 225 minus 144 equals 81.
Oh, so x is 9.
So x is the square root of 81.
Which is 9.
This is the reason that we messed up this step is because it's the most common step to mess up, right? Like, you get that number, you're like, oh, 81. No. The last step, remember, is to take the square
Oh, I
root.
thought you purposely did that.
I did do it for this. I mean, I let you do it for this.
Oh.
But yeah. Now, they're not always going to come out to perfect numbers is the other thing, right? I mean, what if I had a triangle and I said, like, this side is 10 and this side is, like, the square root of 7? Is that possible? Can I have a side of a triangle be the square root of 7? Yeah, it's a number, right? It'd be pretty hard to draw this triangle really exactly because the square root of 7 is like a decimal that goes on forever. But I could have a side that has that length. Right? Just because the decimal goes on forever doesn't mean that the length goes on forever. It is a number. It's somewhere on the number line. So how would I find then if this is C and this is our right angle? How would I find C in this?
Would you square the square root of 7?
Yeah, we do the same process we've been doing. 10 squared plus the square root of 7 squared equals C squared. So 10 squared is 100.
100 plus 7 equals
7, yeah, is
equals 107.
okay. So that equals 107, and then what do I have to do? What's my last step? Take the square root. Now, there's not a square root of 107. So I would just give my answer as the square root of 107.
10.3440.
Now, yeah, if they ask you to round it, then you would round it, right? So 10.3. If they wanted us to round it, I'll do a squiggly equals. We round it. Does that make sense? So sometimes you'll see decimals or square roots. Sometimes you'll get decimals or square roots, and that's totally fine. Right? You don't have to have a triangle that has perfect integers for every side. When you do, those are called Pythagorean triples. Okay? And you can actually find out what the Pythagorean triples are. Like the first one is 3, 4, 5. And there's a whole bunch of other ones that you can find where 3 different numbers can form the sides of a right triangle. But if you notice today, I actually only use this Pythagorean triple. Because we had a triangle that had the sides 3, 4, 5. We also had a triangle that had the sides 6, 8, 10. But this is the same Pythagorean triple as this. It's just multiplied times 2. And we also had a triangle that had the sides 9, 12, and 15. Which again is the same Pythagorean triple. We just multiplied each number times 3. Right?
Wait,
So what I'm doing, these are called similar triangles. A similar triangle is a triangle with the same ratio of sides. So if this is 1, this is 2, and this is 3, if I multiply them all times the same number, 2, 4, 6, these two triangles are called similar. They're not congruent. Congruent would be if they had the exact same sides, but they are similar, which means they have slightly longer.
It can have like 9, 12, 15, could you reduce by 3 to make, and then do Pythagorean theorem, and then just write in your answer like 3 times the square root of number?
I think you could do that. I don't know if it's any easier. You know what I mean? I don't know if it makes the problem easier.
I mean, composite.
What?
All the numbers. With the Pythagorean triple. Most of them.
Well, these two are prime and this one's not prime.
Well, are they usually going to be composite?
I don't know the answer to that. Like usually what Pythagorean triples are. I mean, we could find a list of like all the Pythagorean triples and we could look at them and see.
Wouldn't that go on forever?
It's a really interesting question.
It would go on forever.
I think it's possible that it would go on forever. I don't know if it actually would. I mean, because eventually you're just getting into bigger multiples of the triples you already know. So you have to. I mean, I guess probably it goes on forever. But let's look it up. I think it'd be interesting to find out the answer to that.
Was Pythagorean the dude?
Pythagoras. Yeah. So this is named for Pythagoras. The ancient Greeks did a lot of geometry. I think actually the ancient Greeks found most of the Pythagorean triples. They like listed them out also. But yeah, Pythagoras was the guy who kind of put down this theorem and then named it after him. I don't know anything about him. Wish I could sound smart for the video. Oh yeah, but I have no idea who he is. All right, you guys understand that? It's kind of the basics. We can use this to either confirm whether a triangle is right or to find a missing side. Just remember, if the missing side is not the hypotenuse,
Then you
you're
have to
subtracting. And you're not always going to get integers. So it's fine to have the square root or to round the numbers. All right, that's it.
Oh, that's even